In this example, we're going to look at calculating the limiting reactant, theoretical yield, and percent yield. So here I'm given a reaction of calcium oxide with ammonium chloride to make ammonia gas, water, and calcium chloride. And I want to know if I start with 112 grams of calcium oxide and react it with 224 grams of ammonium chloride. And I did this in a lab, and what I actually got when I did it in the lab was 16.3 grams of ammonia. I'd like to know what's the limiting reactant, what's the theoretical yield, and what's the percent yield. So to figure out the limiting reactant, this is much like baking at home or cooking at home. If you were to try and make pancakes and you had a dozen eggs, an entire 5-pound bag of sugar, but only 1 cup of flour, you're running out of flour, then the flour is going to limit how many pancakes you can make. It doesn't matter how much sugar you could have an entire basement full of sugar. What matters is that you only have 1 cup of flour. So we're looking at the same thing here. We want to figure out if I have a certain amount of my reactants. I have 112 grams of calcium oxide, and then I have 224 grams of NH4Cl, ammonium chloride. Which one of those limits the amount of products I can make? Which one is the limiting reagent in my recipe? And my recipe is my chemical equation. So I need to look at my chemical equation, and I'm told that I produce 16.3 grams of NH3. That's my actual yield. And so I'm looking at NH3 up here. So what I want to do is I want to look at the calcium oxide and figure out how much product could I make with that. I then look at the ammonium chloride and figure out how much product could I make with that. Whichever one makes the least, that's my limiting reactant. So it's like saying with my flour and my eggs, I have a dozen eggs, I might be able to make 30 pancakes, but I only have 1 cup of flour. So I might only be able to make a few pancakes based on the flour. So I need to figure out which one is limiting. So I'm going to start with the calcium oxide, 112 grams of calcium oxide, and I want to figure out how much ammonia, NH3, can I make with this. So if I use the molar mass of calcium oxide, this is 56.078 grams in every 1 mole. So this is converting grams of calcium oxide into moles of calcium oxide. Now I can look at my chemical equation, and I can look at for every 1 mole of calcium oxide that reacts, I produce 2 moles of NH3. So for every 1 mole of calcium oxide that reacts, I produce 2 moles of NH3. And I'm going to go one step further and turn this into grams, because ultimately I'm going to need that for a later step in my problem. So if I look at the molar mass of ammonia, NH3, that is 17.031 grams. And so this is converting grams of my reactant into grams of my product. I'm figuring out for 112 grams of calcium oxide, how much ammonia can I make? This would make 3,814.9 grams of NH3. And I haven't rounded yet, I'll do that at the end. All right, so that's if I start with my calcium oxide. Now what happens if I start with my ammonium chloride instead? So I was told that I have 224 grams of ammonium chloride. So the first thing I need to do is convert this into moles. 4 hydrogens, 1 nitrogen, and 1 chlorine is 53.489 grams in 1 mole. So that converts grams of ammonium chloride into moles of ammonium chloride. The next step is to look at my chemical equation. This time I have a 2:2 ratio. So 1:1 or 2:2. So for every 2 moles of ammonium chloride that react, I produce 2 moles of ammonia gas. And then the last step here is going to be exactly the same as above. The molar mass of ammonia is 17.031 grams in 1 mole. And then I double check my units again. Here I had moles of ammonium chloride canceling with moles of ammonium chloride, moles of ammonia canceling with moles of ammonia. And this is going to tell me if I multiply 224 by 17.031 and then divide by 53.489, this gives me 71.322 grams of NH3. So now I need to compare these two. So I had 3,800 grams or so up here and only 70 grams down here. This means that the ammonium chloride is my limiting reactant because it's limiting how much product I can make. And so this also tells me that my theoretical yield is 71.3 grams. I rounded to 3 sig figs here of NH3. So in my pancake example, the ammonium chloride is my flour. That's limiting how much product I can make. It doesn't matter that I have enough calcium oxide to make almost 3,800 grams of ammonia because I only have enough to make 70 grams of ammonia based on ammonium chloride. So this is my theoretical yield here. But when I did this in the lab, what I collected was 16.3 grams of ammonia. So my reaction didn't go very well. I only produced about 16 grams, but what I should have produced was 71 grams. And there's a lot of reasons for this. Usually reactions don't go completely perfectly. Human error has a lot to do with this as well. But I want to figure out what's my percent yield. How well did I do in this reaction? So the percent yield is always the actual yield divided by the theoretical yield times 100. So my actual yield, what I collected in the lab, was 16.3 grams. And I could compare moles too, but I need to make sure I keep my units consistent. So if I have an actual yield in grams, then I need my theoretical yield in grams because I need my units here to cancel out. So I'm dividing 16.3 divided by 71.3 and multiplying by 100. And this gives me a 22.9% yield.